Here is the second version of the solver problem, which is to solve with constraints. So here, using constraints allow us to solve more complex problem. Constraints are rules that solver must follow. It can be used when there are certain restrictions, and it can be used when there are more than one possible solution. And solver can use multiple variables, but only have one objective cell. So sometimes if you want to maintain multiple objectives, you may need to put those objectives as constraints. So what does that mean? Let's look at this example. So if we were to find x, y, and solve this system of equations, 12x minus 7y equals to 106, that's equation 1, and equation 2 is 8x plus y equals to 82. One thing that you can do if you don't want to do the constraint version, what you can do is you can convert x and y into this format, into the slope-intercept format, and solve them in the previous way, in the difference of y's, and eliminate the difference, right? So that's one thing. But here, I'm going to introduce to you another way of doing this, which can avoid calculation, right? In order to make the conversion from the standard form to the slope-intercept form, you need to do a little bit math. So here, let's just avoid math overall. So this example is noted as example B system of equations. Okay, and I've copy and pasted these two equations for reference. And here we have x and y. We have both x and y, and we let them to vary. Okay, the first one is equation 1. Okay, its left-hand side is 12 times of x minus 7 times of y. Again, I like to highlight them. Okay, and the right-hand side is 106. And for equation 2, its left-hand side is 8 times of x plus y. And its right-hand side is 82. Okay. All right, so now what we are doing? We want to make one equation to hold, given that the other equation holds at the same time. So that's what you want to do. So solver, say we are to aim at the first equation, and we wanted to take the value of 106, which is the right-hand side, right? So in that way, the first equation is set as a goal, and our goal is to have it equal to each other, right? Have the first equation to hold. And then we change the variables. Here we allow both x and y to be variable, right? We want to find the x and y that now we want to have the xy that holds the first equation. And we also want to have the x and y that holds the second equation. Okay, you can either key in 82 or directly click on this number. Either way should work. So here we really don't know if x and y are non-negative or not, so we just uncheck that. And we hit solver. And here is the result. When x equals to 10, y equals to 2, the left-hand side of equation, which is 12x minus 7y, is 106. And also the left-hand side of equation 2 is 8 by x plus y, 8 by 10, which is 80, plus y2, which is 82, and it equals to the value of the second one. So here what we did is we set holding the first equation as our goal by changing x and y. And here we asked Excel to satisfy the second constraint, which is the left-hand side of the second equation equals to the right-hand side of the second equation. So now, technically, we are solving for x and y that make these two equations to hold at the same time, namely solving the system of equations. That's how we do it with the constraint method. And here, I actually like this method because we don't need to convert 12x minus 7y into the form of y equals to whatever x, right? You don't have to do any math at all. You just tell the story. So what I'm telling my students is solver is a storytelling, right? You want to have the first equation to hold, and you set that as the goal. You ask solver to actively doing that, looking for the x and y to satisfy that. And at the same time, you ask solver, hey, as you're doing this, another thing you need to pay attention to is also to make sure the other equation, for equation 2, the left-hand side equals to right-hand side. In that way, both equations are satisfied.